If you remember back to when we brainstormed why we should study environmental issues, two concepts that often came up were resource depletion and pollution. Indeed, these two concepts are a helpful way to categorize issues as we begin to study environmental science. It's not perfect, and some environmental issues and opportunities don't fit neatly into one class or the other, but it's a place to start. In fact, in order to effectively study something, scientists often break the issue into manageable units. Consider studying a frog in your biology class. You might first study the skeletal system, then the digestive system, a reproductive system, etc. Of course, there are drawbacks to this type of reductionism, as we must always remember that the parts interact and affect one another. Nonetheless, lumping things together into classes is often a useful way to start a study. So that's how we'll start. Resource depletion and pollution. It's not perfect, but many issues that we'll discuss can fit into one of these two categories. Notably, your textbook lists resource use and pollution as two of the three causes of environmental issues, the third being population size. I see the textbook's author's point, but for our purposes, let's consider these two to be two different classes of issues, and we'll consider underlying causes soon. Here's a few typical environmental issues. Which of the two categories would you put them in? Pause the video for a moment and quickly assign each to either resource depletion or pollution. The next few slides deal with building up our understanding of each of these two classes. Resource depletion is one of our two categories of environmental issues. Before we start talking about specific natural resources, we first need a definition of what we mean by a resource. Resources are anything we get from the environment to meet our needs and our desires. Pause here and take a moment to brainstorm a list of natural resources. Feel free to browse the table of contents of your text. Compare your list to the list below. Did you miss any that I listed? Did I perhaps miss a few that you listed? We can further divide up these resources into renewable and non-renewable resources. See the definitions in your text. Check out your list and divide it into renewable and non-renewable resources. Are there any that you're unsure about? Pause the video and classify each resource on your list as renewable or non-renewable. Non-renewable resources are finite and are not replaced in a timely fashion, and could theoretically be used up on a human timescale in hundreds or thousands of years. Of course, in reality, we are unlikely to completely, 100%, exhaust a non-renewable resource, but it could get low enough so that it is no longer economically extractable. Oil is a good example of this concept. Oil is a non-renewable resource, but we are unlikely to ever use the very last drop of oil that exists in the earth. Interestingly, though, if we all only used 1 drop of oil per year, oil would be a renewable resource. Okay, that's unlikely. But the point is that whether a resource is renewable or non-renewable sometimes depends on the rate of its use. In that regard, we sometimes refer to some renewable resources as potentially renewable. These resources are replenished fairly rapidly through natural processes, in days or decades, but they may be depleted if overexploited in the short term. Perhaps the overexploitation is due to poverty, rapid population growth, or forced export from developing countries. For example, in some regions of the world, such as parts of Eastern Africa, wood is an example of a potentially renewable resource. It's technically renewable. However, it is currently being used at an unsustainable rate. And in this case, poverty is the primary driver. Another concept related to natural resources is the concept of a reserve. Reserves are known deposits which can be economically extracted at current prices. Obviously, reserves of a resource, such as oil or natural gas, decline as more and more is extracted, and the reserves increase as more of the resource is discovered. How else can a resource reserve go up or down? Consider the second part of the definition, economics. Reserves can increase as new technologies are developed to make the process cheaper. For example, both oil and natural gas reserves in the United States have increased in the last decade, not because we found new oil and natural gas, but because of new technologies, newly developed extraction methods, fracking, hydraulic fracturing in particular. Additionally, reserves also expand as people are willing to pay more for a resource, thus making oil economically extractable that was previously too expensive to extract. Similarly, oil reserves could go down if the competing fuels were to become cheaper and easier to use, or if we started internalizing all the external costs to oil, like oil spills and other things like that we're going to be talking about later in the course. Putting all of these external costs back into the price of oil might make it prohibitively expensive, and thus our oil reserves would go down. The United States Energy Information Administration is the place to go to get reliable information on United States energy production and use. If you're interested, here's a link that discusses the United States oil and natural gas reserves, though you can navigate from that site to other places within the administration. Lastly, it's worth noting that the economic growth of Europe during the 18th and 19th centuries, and the United States during the 19th and 20th centuries, was made possible due to the exploitation of other countries' non-renewable resources. This trend continues today as the developed world extracts resources from lesser developed countries and regions of Africa, Latin America, and Asia. There are many pros and cons of this sort of globalization of resource extraction. I look forward to our discussions later in the semester. Pollution is the second of our two classes of environmental issues. Although you probably have a good intuitive idea of what pollution is, we'll start with a definition, just to get everyone on the same track. Pollution is any addition to air, water, soil, or food that threatens health, survival, or activities of humans or other living organisms. Notice that something can be considered pollution if it somehow harms other organisms, not just humans. Notably, pollutants can enter the environment naturally or anthropogenically, which means by humans. Pause briefly and brainstorm some examples of natural pollution and some examples of anthropogenic pollution. Additionally, pollutants may remain local, or they may be transported great distances by wind or water. Pollution knows no borders and routinely moves from one state or country to the next. A few examples might surprise you. Here in California, we experience air pollution from industry and power plant sources in China, though we can't be too quick to blame them for our problems, as much of this pollution is created to produce cheap products that we buy. Also, Inuit women living in a traditional subsistence lifestyle above the Arctic Circle have levels of PCBs, an industrial pollutant, in their breast milk that are higher than virtually anywhere else in the world. Shocking! They live nowhere near industry and do not benefit from the industrial processes. Another distinction we can make is whether the pollutant is degradable or non-degradable. Degradable pollutants may be broken down completely or to acceptable levels by physical, chemical, or biological processes. For example, many, but not all, components in sewage and gasoline are biodegradable. Non-degradable pollutants cannot be broken down by natural processes or are broken down very slowly. PCBs, and also MTBE, an additive that used to be put into gasoline, are examples. These chemicals are non-degradable or recalcitrant. A final, very important distinction is between point source pollution and non-point source pollution. I want you to be very sure that you understand the difference between these two. Point sources are single, large, identifiable sources. Non-point sources generally involve many diffuse sources, often very small in nature. For air pollution, point sources might include coal-burning power plants, large industry, etc. Non-point sources might include agricultural dust blowing off of thousands of acres of farm fields, smoke coming out of every home chimney, and exhaust from cars. Indeed, cars are a great example of non-point sources. Not only are there many of them spread out all over, but they're also moving. Which of these two, point source or non-point source, is likely more difficult to deal with? Why? Be sure you can give examples of both point source and non-point source sources of pollution for both air pollution and water pollution.